This video is on how to construct a dilation about a center. You will need two things, a straight edge and some colored pens. So this problem has a scale factor of 3, and we're going to dilate this or make it larger by that factor. So the first thing we want to do is use our straight edge to draw a line from the center of dilation through one of the vertices. Make sure you draw your line long enough, because remember, we're making this 3 times as big. Our next step, we're going to use our straight edge, which in this case is a piece of paper, to measure or to mark the length between the point and the vertex. So line up your paper that the corner is right in the middle of the dot. Then use your colored pen to mark where the vertex is on your piece of paper. So the original spot where we just marked is 1. Now we're going to slide that corner to the vertex. That will be 2. Put a little mark there on the paper and slide it one more time. And now put your final mark. So this point is now 3 times as far from that original dilation point as the vertex. We're going to repeat this process now for the other 2 vertices. Use a different colored pen for each vertex. Remember, use your straight edge to draw a line from the center of dilation to the vertex. Extend it a long distance so you can get all 3 in there. Our next step was to mark the length or the distance from the point to the vertex, lining up the very corner in the center of your center of dilation, or your point of dilation. Mark it. Now be careful. Make sure you're using the same color. See how we have the orange pen in our hand? We're on the orange line. Make sure you use that orange mark on your paper. Now slide your paper so that corner is on the vertex. Put a mark. That's 2. Now I need 1 more to get to 3. There's our final dilation point. And now we'll do our last vertice. This time we'll use green ink. So we draw our line from the center of dilation through the vertex and extend a good distance beyond. And now we'll measure corner of the paper in the center of the dot, mark the vertice. That's 1 distance, or the original. We'll move it down. That corner is right on the vertex. Mark my 2nd distance. And finally, we'll move to our 3rd distance. So now we have 3 lines and a bunch of dots. We're going to use these 3 dots here, all of our 3s, and connect them to draw our final dilated triangle. Nice straight lines are key here. That would be our dilated triangle. Let's shade that in a little bit so we have clear communication about where that is. There, now we can see it better. Now we don't do dilations or any of our constructions without talking about their properties. But in order to talk about their properties, we're going to want some labels on these vertices just to make it easier and convenient. So let's label these triangles D, E, F. So our original is D, E, and F, and our final product, remember, would be D prime, E prime, and F prime. So triangle DEF is the pre-image, and D prime, E prime, F prime is our image. So we could write our first statement. We know that triangle DEF is similar to triangle D prime, E prime, F prime. We also can talk about their scale factors. Let's point those out and then we'll write them down. Our scale factor, remember, was 3, which means that each one of these segments from the original pre-image is now 3 times as long in the image. So let's write a scale factor. Scale factors are always the image over the pre-image. So D prime, E prime over DE would equal 3. E prime, F prime over EF also equals 3. And finally, D prime, F prime over DF also equals 3. So dilations are a similarity transformation, which means all of their angles are congruent because they are still similar. So we could write that angle D is congruent or equal in measure to angle D prime. Angle E is congruent to angle E prime. And angle F is congruent to angle F prime. And that's all you need to know about dilations.